going to discuss the physics behind kicking a soccer ball.
Because the ball is not moving, there is no torque acting on it.
However, now look at how Alex kicks the ball across the carpet. Whenever a ball comes into contact with a surface that has friction, the ball's parallel velocity is changed and a torque is applied to the ball by the off-center force. When the foot comes into contact with the ball, the upward and forward straight swing of the leg stroke gives the ball top spin.
Next up is soccer ball heading.
You always have to head the ball from the direction it was served in. Let me demonstrate. Wow!
Okay.
That is what not to do. Let us do
Yeah.
it again.
Let's
You
try
go
it one
this
more
time.
time. Hold this. Okay, ready?
I'm a journalist.
There you go. Okay.
This is because vectors of motion need to be considered.
So here's an example problem of that we're going to do on the board.
A soccer player aims a header 2 meters above the ground at an angle of 32 degrees. If the initial velocity of a soccer ball is 8 meters per second, what is the distance traveled by the ball?
Here's the solution. We first need to determine the components of the initial velocity. So the x velocity is equal to vx, which equals v cosine theta, and the y velocity.
What?
The y velocity is equal to vy, which equals v sine theta. Okay, so then that is 8.0 meters per second times the angle, or cosine theta angle. So that ends up being 6.78 meters per second. And then second one is same thing, except it's sine 32 degrees, which is equal to 4.24 meters per second.
Now we can use the y velocity to calculate the amount of time the soccer ball was in the air. You can set y to 0 and y equals 2.0 to show that we want to know when the ball hit the ground.
It does not work. That doesn't work either.
Oh, okay. No, what is this one? Sorry, Mr. Drew.
I'm just going to say what you're writing.
Okay.
So she's writing y equals y plus v to the JK, so I'm not saying what she's writing. She's writing the formula. And then after that, we're going to plug in the y equals 0 and y to 0 equals 2 into the formula.
So using the quadratic formula, which you all know how to use, I'm not going to write it all out right now, you get t equals, t being time, 1.20 seconds.
Okay.
So to find the range, we can substitute this time value into the equation for the x position. And that's equal to 8.16 meters.
Which is the distance. Thank you.
The end.
Also